Hello, we are discussing about GATE 2008 ECE paper. Consider the following assertions. Statement 1. For Zener effect to occur, a very abrupt junction is required. Step 2. For quantum tunneling to occur, a very narrow energy barrier is required. Which of the following is correct? There are four options are given. Okay, related to step 1 and statement 1 and statement 2. First of all, for Zener effect to occur, a very abrupt junction is required. PN junctions are of two different types basically. Okay, practical PN junctions are going to be of basically two different types, which is nothing but abrupt, or it is also called as step graded junction. Abrupt or step graded PN junction. The other one is nothing but linear graded junction. So abrupt implies nothing but the change in concentrations are going to be very much abrupt. It is going to be looks like this one. This is positive charge present in depletion region, and it is negative charge present in depletion region. It is center of PN junction, that is nothing but middle of PN junction. So if you observe, this is 0 plus, you can say it as 0 minus, and it is 0 plus. So at 0 minus you will get a large positive charge, and at 0 plus you will get a large negative charge. This is negative and it is positive. So at 0 minus you will get large negative charge, at 0 plus you will get large positive charge. So if you observe at t is equal to 0, you cannot say whether the charge is 0 or positive or negative. So that there is a abrupt change from the large negative value to large positive value at t is equal to 0. This type of junction is called as step graded or abrupt junction. Whereas the charge carriers carrier whereas the carrier concentration in depletion region, if it is changes linearly in this manner, towards negative to positive at that time, this is going to be called as linear graded junction. Okay, so for Zener effect to occur, is it necessary that a very abrupt junction is required? This statement 1 is going to be false, because there is nothing is guarantee that one. Only Zener effect happens in step graded junction. Zener effect can occur either in linear graded junction or in step graded junction. So it is not necessarily be abrupt junction. Okay, but what it requires is nothing but Zener diode requires very high doping on both sides, P side as well as N side. But it should not be such that it must be abrupt junction. It can be any type of junction. And statement 2. For quantum tunneling to occur, a very narrow energy barrier is required. Zener diode also works on the principle of tunneling effect. Tunneling effect is going to be, tunneling phenomena is nothing but, instead of surmounting the potential barrier, okay, the charge carriers will go through, that is nothing but penetrate through the potential barrier whenever it is that much small. Since Zener diode is going to be very much heavily doped, such that the potential barrier is going to be very small even under reverse bias also. So the potential barrier is going to be very small, that becomes very narrow, such that the charge carriers from one side to other side, they don't go through the potential barrier, that is they don't jump on the potential barrier, they can go through the potential barrier at the same energy level. Okay, this process is called as surmounting, this process is called as tunneling phenomena. Tunneling is nothing but instead of surmounting, instead of jumping the potential barrier, the charge carriers are moving from one side to other side through the potential barrier. Okay, for that one it requires a very narrow energy barrier is required. That is statement true is false. So the right option for this one is nothing but A. Only statement true is true. So if you observe, I will clarify this surmounting potential barrier and tunneling phenomena. So if this is going to be ordinary PN junction with depletion region like this side is P and its side is N, at that time the holes, only I am going with holes. Okay. Only I am going with electrons. For example, electrons are going to be moving from n side to p side under forward bias, so electrons has to move in this direction. Electron has to move from n to p in forward bias. In forward bias, electron has to move n to p is nothing but electron has to move from conduction band of n side to conduction band of p side. By that time, conduction band of p side will be at higher energy level and conduction band of n side will be at lower energy level. The difference between this one is nothing but V naught, potential energy barrier, or it is specified as E naught. E naught is nothing but energy barrier. Okay. E naught is specified energy barrier, potential energy barrier E naught. E naught. Now, so the electron now it has to jump into this side. This process is going to be called as surmounting the process, that is jumping over the potential barrier, surmounting phenomena. Whereas if it is Zener diode or tunnel diode, at that time, okay, the potential barrier is going to be very narrow. Potential barrier is very narrow. Okay, because both are going to be heavily doped. By that time, even though there is a potential barrier difference, is going to be in this manner. This is mm, this is conduction band of n side and it is starting point of conduction band of p side. Okay, whenever in forward bias, if the electron has to move, at the time it don't go jump over this E naught. This don't go for the jump over this one, and this electron will move in the same energy level from one side to other side. The condition is nothing but one side the energy level must be empty, the other side energy level must be filled, so that an electron can go through the potential barrier at the same energy level. If the condition satisfied that one side of the energy level is going to be empty, the other side of the energy level is going to be filled. So by that time, from filled energy level, electron can move into the empty energy level on the other side. This process is called as tunneling phenomena. Tunneling phenomena. Okay. Thank you. The right option for this question is A.